Hi, it's Chris from Flip Math. I'm going to take you through today's lesson, which is part of the algebra section, but it's moving on to C1 Algebra, and it's part of the C1 module for AS Maths. Objectives of today's lesson: we're going to detail a four-step process or four-step thought process for simplifying complex polynomials, and then simplify complex polynomials as far as possible. You know, algebra, so many people seem to hate it in life, but hopefully, as an A-level student and what we've done so far, you've seen its kind of problem-solving power as we've been going. So, first thing I'm going to do, I'm going to go over what we've covered, like the clip notes, and we're going to see what we've covered in the 4 units from 1.1.1 to 1.1.4. If you're not sure what they are, you can go to the site on flipmath.co.uk and check those out. But the units we've covered so far have been, right, the first part was just refreshing your GCSE algebra, so how you solve for an unknown variable using x, and how you multiply brackets, and how you generally solve, and we threw some algebra or fractions in with the algebra there as well when we were doing that. Okay, the second one, C1.1.2, was we looked at quadratic equations and then solving, factorizing and multiplying out per brackets, factorizing into them. Then we looked at the three special cases, so the complete and the square, the quadratic formula, and the difference of two squares in there. And that's what we covered there. In the third one, we looked at the surd and the definition of a rational and irrational number, and how to simplify and work with surds. And the fourth part was how we work with indices and their own set of rules for how we deal with for indices or powers, and the notation we've encountered. So basically, we're going to combine all these ideas because they're all kind of GCSE elements, even though I took them, to the very edge of the GCSE and onto the fringes of the C1 and the A-level course. We're going to put them in one big mixing bowl and use them to solve other problems. So there's a mixing bowl. I'm going to mix them in. Any weaknesses that you're going to have are going to be tested and probed, and that's a good thing, because at this stage you're going to see exactly what you can do and what you can't do, and don't be afraid if you find there's big gaps, because this is exactly what you want to do. You want to know now so that you can see the progress that you make over the course of not only this year but next year as well. And I can tell you, no matter how wonderful you are now, it'll be unrecognizable to what it'll be at the end of the 2 years. You'll see how second nature things will be to you by that stage with how you deal with your algebra. So let's go. Best way to learn algebra is to practice it, and we're going to do that a lot. I'm going to show you a couple of examples here, and then we'll practice it lots and lots in class, or even get the bits off the website. So, four-step process for simplifying complex polynomials. You may not always use the 4 steps or do them in the same order, but it'll give you an idea and feel for the things you should be doing, the thought process you should be going through all the time when you get one of these problems. So the 4-step program I'm going to lay out is this. You're going to multiply out terms on the top line. So, multiply out any brackets they've got on the top line. The end result is usually, at the end of the problem, is to have everything in paired brackets, much like a quadratic expression. So x squared plus 3x plus 2 becomes x plus 1 upon x plus 2, and vice versa. And that's from the second unit, the C1.1.2, if you're not sure how to do that. So we're going to end up with that at the end of this thing. So we're going to multiply out of brackets so that we get the x squared plus 3x plus 2 bit at the start. So we're going to start with this, probably, or some form of this, and multiply them out as we go along. Second bit, we're going to collect any terms together. So collect any terms that go like terms. So x squared terms go with x squared terms, number terms go with number terms, etc. So something like x squared plus 3x plus 2 plus 2x squared minus 2x minus 4. You can see that there's an x squared term there. There's plus 2x squared. If I add those two bits together, I'll get 3x squared. Similarly, plus 3x minus 2x gives me plus 1x, and plus 2 minus 4 gives me minus 2. And you'll see how that gets put together. Again, that's the first unit, C1.1.1. Third step is to factorize whatever we've got left, and these lovely lines are going to stay there. So once we've collected our like terms together, the new expression may factorize into paired brackets again, and in many cases it will. So 3x squared plus x minus 2 will become 3x minus 2x plus 1. Again, you can go back to the second unit for some help with that. And fourth, but least, is to simplify anything again. So we're going to look for common terms that are on the top and the bottom of our fractions, And there should be multiple brackets that cancel out, leaving a simpler answer at the end. All this is very theorized, and probably doesn't make much sense until we go ahead and use it. And I stuck QED at the bottom, and you will get well used to the fact that we stick QED at the bottom to say quite easily done when things generally aren't really quite easily done. It's a badge of honor to stick QED at the bottom and say, look what I can do. Okay. So let's look at a problem. So we're going to simplify the expression x upon x plus 3 plus 2 over x plus 1. At first look, it doesn't look like anything cancels easily. Assume nothing, we have 4 stages to work through. So we're going to multiply out, collect, factorize and simplify in each bit, and we're going to start off with the multiplying out. The only aspect that we can multiply out is the top line, and it's usually only the top line you're going to think about. So we're going to multiply the x upon x plus 3, and then the plus 2. When we multiply that out, x times x gives me x squared, x times plus 3 gives me plus 3x, and we'll have a plus 2 in the end. Combining this with the whole problem, that's x squared plus 3x plus 2 in the top line, what we got when we multiplied that out, over x plus 1. Okay. Collect. There are no terms to collect in this problem, but it's always good to check. It should be part of your thought process. Same way this isn't a very strict 4-step. You know, these are the 4 things you should check. As you do more of these examples, it'll become kind of second nature. You'll not think of it as a 4-step process. You'll just get into a way of multiplying out and playing with the algebra, so that you know, when you become more comfortable, you'll feel more comfortable in trying things and undoing them by factorizing, etc. out. So the third part is to factorize. So we have a quadratic in the top line, which factorizes into a pair of brackets. So we're looking at the 2 numbers that multiply together to give you 2 plus 2, or the 2 factors plus 2 that add together to give plus 3. That's plus 1 and plus 2, and that factorizes down to become x plus 1 upon x plus 2. So now, if I combine that together, the top line becomes x plus 2, x plus 1 upon x plus 2, and you'll notice that the whole way along I've kept the x plus 1 in little brackets at the bottom, because as you can see, when we come to simplify, that looks identical to that one down there, and the same term, top and bottom, x plus 1 over x plus 1, just cancels out to give 1, and that whole expression cancels down to give us the answer x plus 2. Now you might need to watch through that again to spot all the points, but you can see how what we've done in the first couple of units, 1 and 2, really produce what happens next. Do you know what I mean? You have to use those skills to solve this problem. So I'm going to take it back to fractions a little bit. I want to remind you about how we combine fractions when adding or subtracting them. And again, we did this some in the first unit, but I'll do it again. So 2/3 plus a quarter. If we consider what way we would solve that, you would not find it odd to use the term find a common denominator at this stage. So you want to get the lowest common multiple of 3 and 4 at the bottom, which is what our common denominator is. That will be 12. And 2/3 becomes 8 over 12 because we multiply top and bottom by 4. And a quarter becomes 3 over 12 because we multiply top and bottom by 3, and that'll get us to 12. 8 over 12 plus 3 over 12 gives us 11 over 12 as our answer for that. Algebra terms would do the same. We're going to consider 1 over x squared plus 2 over xy. Now if I was getting the common denominator here, or the lowest common multiple, the two common denominators are the two denominators that start are x squared and xy. The lowest power of x that satisfies both is x squared, right? So the lowest, that must be at least x squared if we look at the x's. And for y, well, there only is one y term, and the lowest power of y that satisfies both is y. So our common denominator is x squared y. So we're looking for the highest power of x, the highest power of y, and that becomes our common multiple at the bottom. Okay. To get x squared to become x squared y, we have to multiply by y. So we'll multiply top and bottom by y to give us 1 times y gives us y, and x squared times y gives us x squared over y. To get from xy to x squared y, we'll have another x to multiply by, so we're going to multiply top and bottom by x. That gives me x squared y on the bottom, and 2 times x is 2x at the top. That gives us an answer of 2x plus y over x squared y, and that's how we combine fractions and algebra. Okay, you may need me to go over that in class. Take a note of it, and we'll certainly come to it. I would be surprised if you didn't. So let's go for another example. We're going to simplify the expression 1 over x minus 3 minus 1 over x plus 3 plus 2x over x squared minus 9. It looks very complicated, but take some of the ideas that we've just had, and again, the things from the first couple of units that we did as well. So we're going to go through our 4 stages. I'm going to stick them down on the right hand side there. We need to find our lowest common multiple of x minus 3, x plus 3, and x squared minus 9. Now I picked this example for a reason to show you, because this is quite tricky. As this explained to you when we were doing the quadratics, you just recognize that x squared minus 9, when you factorize it, is the difference of two squares. And the difference of two squares, and you go back to your examples in the second unit for this, when I factorize that, that becomes the square root of x, the square root of 9, plus and minus between them. So you get x minus 3, x plus 3. So, which is, funny enough, what is the bottom of these. So this one would be 1 over x minus 3. This is 1 over x plus 3. And this one here, if I just rewrite this for a second, this here actually becomes plus 2x, not forgetting our sign, over the x minus 3, x plus 3. That's what that becomes. Okay, a little bit messy, but you get the idea. When I factorize that down, that's it. So I recognize that that factor is part of that, that factor is part of that, so the lowest common multiple that we need is these two things multiplied together. So getting a common denominator gives, I've multiplied this out and combined it to be x squared minus 9, but I really should have kept it as x minus 3x plus 3. To get this multiplied by x plus 3 in the bottom, I'm going to have to multiply the top by x plus 3, so then I have 1 times x plus 3. This one, to get it x plus 3, x minus 3, I have to multiply top and bottom by the x minus 3, so that's minus 1 times the x minus 3. And this one's already over the lowest common multiple already, so it's plus 2x. We're going to multiply that out. So 1 times x is x, 1 times 3 is 3, minus 1 times x is minus 1x, and minus 1 times minus 3 is plus 3. Be careful of that. Plus 2x. That's our multiply out. Next, we're going to collect our terms. So if an x minus an x plus 2x gives me 2x, and then a plus 3 plus a 3 gives me 6, and that's over x squared minus 9. Now, one of the reasons that I kept this x squared minus 9 at the bottom is so that I could give you something to factorize here at this stage. So when I factorize the x squared minus 9, I get x plus 3 times x minus 3. And if I factorize the top, the only thing that I have in common is a fast come factor of 2. So if I divide both by 2, I get 2 upon x plus 3. Last thing to do is to simplify with an x plus 3 in the top, an x plus 3 in the bottom, which cancel out and give us 2 over x minus 3. Now, I can guarantee you that is difficult, right? If you're looking at this and going, my word, that's really difficult, it is. However, I wanted to give you another example that was difficult, that you see the things you're going to work out. It's only through a lot of practice that this will become second nature to you, and you will get good at it if you practice it. And it's such a good skill for even taking through on the A2 modules next year. It's really, really quite handy. So example 3, we're going to simplify this as far as possible. Again, another one. This is actually from a past paper. There's a lot in this. And I'm going to take it through the 4 stages. Multiply, collect, factorize, and simplify. So I'm going to multiply it out first. I'm going to take this bit first, these pair of brackets first, and I've broken it down and called that part 1. So 3x minus 1 upon 2x plus 3. When I multiply that out using the FOIL technique or the grid technique that we used, we'll get 6x squared. 2 in our terms of minus 1 times 2x is minus 2x. And plus 3 times 3x is 9x. And minus 1 times 3 is minus 3. When I multiply that out, that's what I get. When I multiply out the minus 2 times 4x plus minus 1, I get minus 8x plus 2. So when I put those two side by side, I've got my 6x squared minus 2x plus 9x minus 3, and then minus 8x plus 2. I've multiplied out those bits on the left. Next bit is to collect them. So we have 1x squared term, so it's 6x squared there. I have minus 2x minus plus 9x minus 8x gives me minus x, and then I have minus 3 plus 2 gives me minus 1, and that's divided by the 3x plus 1 3x minus 1. You'll notice that we haven't done anything with this yet. This is very common, this bit to the right did not actually touch at this stage. Unless it was the difference of two squares, always watch out for that. Next thing to do is we're going to factorize 6x squared minus x minus 1. You can use your techniques for doing it, but it's 3x plus 1 and 2x minus 1 will give you it. And remember that when we divide by a fraction, we actually flip it upside down and multiply, so it becomes 3x minus 1 over 3x plus 1 and multiply. So on the top line, we have 3x plus 1. On the bottom line, we have 3x plus 1. They will cancel. And we are left with 2x minus 1 upon 3x minus 1, which is probably the way they want the answer. However, we can also multiply that in together to give us our polynomial of 6x squared minus 5x minus a plus 1. And that's as far as we can simplify it. It still looks quite complicated at this stage, but it looks a lot less complicated than it did at the start. The other thing to point out is at the start there was the 3x minus 1 and the 3x minus 1 there. A lot of students will just cancel those off at the start, but you can't do that until you work through the process of multiplying out, collecting, then factorizing and simplifying. I hope you have a ton of questions, because it's only from asking the questions and trying it and working through the examples that you get better. And it will be a struggle at the start. By the time you go through it and go through it and go through it and go through it and go through it, you'll find that you'll be getting better at it. Now you'll probably not be all the way there by the time we move on from this unit, but this kind of skill will come back a lot over the course of the year. Okay. Next time on C1.1.6, we're going to examine it and formulate strategies to solve indice and surd problems rather than just those quadratic problems that we seem to have had in this lesson. Our objectives in this one were detail a four-step process for simplifying complex polynomials. So that was our multiply out, collect, factorize and simplify. They were 4 steps. And then we did 3 examples of simplifying complex polynomials as far as possible, each of them getting progressively more difficult. And like I say, we've got lots of time and effort and space to do those in class, and we'll spend an awful lot of time doing those. And you'll have the answers there that I'll provide for you as well, so you can check your work, see how you're getting on, make mistakes, and keep going. Hopefully you've kind of seen that we've covered those, even though you'll have to revisit it. Remember, practice, practice, practice is the key. Go to flipmath.co.uk and search for C1 Algebra. Feedback and all resources should be sent to @flipmath or see me in class. You can search in the box at the top of the page for C1 Algebra on the site. Thank you for watching, and I'll catch you next time. Bye.